Hello friends, welcome to Blessed Excellence Center. This is Chemistry Demystified with EB Christian. Today we are looking at calculation of molarity. It's important to have this formula at the back of your mind, that molarity is equal to mole of solutes all over volume of solution in liter. I repeat again that molarity is equal to mole of solutes all over volume of solution in liter. Your presenter remains EB Christian. Molarity is used to measure concentration. The concentration of a solution is the amount of solute in 1 liter of the solution. Its unit is mole per liter or gram per liter. The two types of concentration are molar concentration and mass concentration. Molar concentration is the concentration of a solution in mole per liter. It is otherwise called molarity of the solution. Mass concentration is the concentration of a solution in gram per liter. Now let's look at some important formula we're going to be using in the course of our calculation. And the formula for molar concentration is equal to mole of solutes all over volume of solution in liter. This is very important. And this formula is the formula for molarity. Remember that molar concentration is something as molarity, okay? Then mass concentration is equal to mass in gram all over volume in cm cube times 1000 over 1. Note that molar concentration is same as the molarity of the solution. Now let's look at the relationship between molar concentration and mass concentration. How are they connected? Now, molar concentration is equal to mass concentration over molar mass. Density in gram per liter is equal to mass in gram all over volume in ml. Then mole is equal to mass in gram all over molar mass in gram per mole. This formula is very important. There are also some units that are important in the course of this molarity calculation. Let's look at some of them. 1 liter is equal to 1 dm cube, which is equal to 1000 cm cube. It's important to also note that 1 liter is equal to 1000 milliliter, and then 1 gram is equal to 1000 gram. At this point, let's consider a specific question, that is calculation. What is the molarity of each of the following solution? A. 0.29 mole of sodium hydroxide in a 350 ml of solution. B. 50 gram of sodium hydroxide in 300 ml of solution. And finally, C. 600 milligram of potassium iodide in 250 ml of solution. So let's begin to address the question one after the other. Solution given number of mole for A. Number of mole is given to be 0.29 gram. Okay, then the volume of solution is given to be 350 ml. So since the volume is given in ml, we have to convert it from ml to liter. Remember that 1000 ml is equal to 1 liter. So to convert 350 ml to liter, we divide it by 1000. And that is why we have 350 divided 1000. So if you divide this by this, you're going to have 0.35 liter. Okay, good. Now, what's the formula for molarity? That molarity is equal to mole of solutes all over volume of solution in liter. So the mole of solute is given to be 0.29 mole, which is what you're seeing here, 0.29 mole. And then the volume is given to be 300 ml, which we convert it to 0.35 liter. So that gives us 0.35 liter. If you divide this by this, you're going to have 0.828 molar. So that is the molarity of the solution. Now let's look at the next part of it, solution to B. In question B, the mass of the solute is given to be 50 gram, and then the volume of the solution is given to be 300 ml. We have to convert the 300 ml to liter. And if you convert 200 ml to liter by divided by 1000, you're going to have 0.30 liter. In this case, we have to, the mole of sodium hydroxide is not given, so we calculate the mole of sodium hydroxide. And you know that mole is equal to mass over molar mass. The mass is given to be 50 gram, but the molar mass is not given, so we have to calculate the molar mass. Watch my video on how to calculate molar mass for more information on this. So the molar mass of sodium hydroxide is equal to 23 being the molar mass of sodium plus 16 being the molar mass of oxygen plus 1 being the molar mass of hydrogen. If you sum all of this, you're going to have 40 gram per mole. Then the mole of sodium hydroxide will be the mass over the molar mass, which is the mass is given here to be 50. So we have it as 50 gram all over the molar mass. We calculated it to be 40 gram per mole, which is 40 gram per mole. So if you divide it by, you're going to have 1.25 mole, which is the mole of the solution. Now molarity is equal to mole over volume. The mole, we calculated it to be 1.25 mole, and the volume, look at it here, 0.30. So we have it 0.30 liter. So divided by this, we're going to have 4.17 molar. That is the molarity. We know molar is the same thing as mole per dm cube or mole per liter. Okay, good. Now let's look at the solution to question C. In section C, the mass of the solute potassium iodide is given to be 600 milligram. You have to convert the milligram to gram by dividing by 1000. That's why we have 600 divided 1000, and that gives us 0.6 gram. Now the volume of the solution is given to be 250 ml. So convert the ml to liter by dividing it by 1000, and that gives 0.25 liter. Okay, good. So the molar mass of potassium iodide is 39.1 plus 126.9, because the molar mass of potassium is 39.1 and that of iodine is 126.9. That summation gives us 166 gram per mole. Watch my video on how to calculate molar mass for more information on that. Okay, good. Now the mole of potassium iodide is the mass, the given mass, which is 0.6 gram all over the molar mass, which we calculated to be 166. So 0.6 divided 166, that gives 0.0036 mole. Now molarity of solution would be the mole, which is 0.0036 mole all over the volume, which is 0.25. If you divide this by this, you're going to have 0.0144 molar or mole per dm cube, which is the molarity of the solution. Thanks for watching. If you've not yet subscribed, do well to subscribe. Click on the notification bell, share the video, drop your comments, don't forget to like it.